This sample problem is related to static and kinetic friction and how it's related to the applied force. A certain wooden block of mass 7.6 kilograms is pulled along a surface with a uniform speed. The coefficient of static friction is 0.4 and the coefficient of kinetic friction is 0.25. First question, how much force is needed to get the block moving? Second question, how much force is needed to keep the block moving at constant velocity? So for the first question, how much force is needed to get the block moving? If this block is initially at rest, in order for us to be able to make this move, we must exert an applied force that is much greater to the static friction. Let's write that down. The applied force must be greater than the static friction in order to make the object move. Therefore, we must solve for the magnitude of the static friction. So the formula is static friction is equal to mu s times the normal force, where mu s is the coefficient of static friction and Fn is the normal force. Now, since this object right here is on a flat surface, that means to say then that whatever the weight of the object is, weight which is equal to mg, that is just equal to the normal force, which is the force exerted by the surface, because the object is not moving along the vertical axis. So once again, if the object is on a flat surface like this, the normal force is equal to the weight of the object, and therefore the normal force is equal to mg. So we have the formula now, coefficient of static friction times the normal force, which is equal to mg. Let's substitute our values. The coefficient of static friction is given to be 0.4 or 0.40 times the mass of the object, which is 7.6 kilograms, times the acceleration due to gravity, 9.8. So our static friction is equal to 29.79 newtons. Therefore, our applied force must be greater than 29.79 newtons in order for us to be able to make the object move. So this is for question number 1. For the second question, how much force is needed to keep the block moving at a constant velocity? Now, since the block is already moving, that means to say that the kind of friction that is present there is kinetic friction. And the block will be moving with constant velocity if the kinetic friction is equal to the applied force. That means to say, in order for us to be able to make the block move with constant velocity, our applied force must be equal to the kinetic friction. Remember that kinetic friction is the kind of friction that exists when the object is already moving. And when the applied force on that object is equal to the kinetic friction, the object will be moving with constant velocity. So therefore, we must be able to solve for Fk so that we would know the applied force that needs to be exerted. So Fk is equal to mu k times the normal force, and then the mu k is given to be, or the coefficient of kinetic friction is given to be 0.25. So we have that information. Now our normal force, once again, is just equal to the weight of the object because the object is on a flat surface. So the normal force is just equal to mg. So let's substitute the values now. We have the coefficient of kinetic friction, 0.25, times the mass of the object, which is 7.6, times acceleration due to gravity, 9.8. So our kinetic friction is equal to 18.62 newtons. Therefore, this means then, therefore, our applied force is equal to 18.62 newtons. We must be able to exert this amount of force, which is equal to the kinetic friction, in order to make the object move with constant velocity. So once again, in order for an object to move, our applied force must be greater than the static friction. And if we would want the object to move with constant velocity, or if the object is moving with constant velocity, that means to say that the applied force is equal to the kinetic friction.